This project is the logical continuation of the previous project, but this time it's the clone of the CoinGecko project or CoinMarketCap. Every 30 seconds, Django performs GET requests to the API of the CoinGecko website, save the needed data to the database, and then sends the data via open WebSocket connection to the front end. And we can see dynamically changing table. If the price raises, it's highlighted with green. If it falls, it's red. I used Vue.js on the front end. The project uses Django Channels, Redis, Celery and Vue.js. It's very similar to the last video. First of all, I want to create a basic Django project with one app and one template. Let's install Django. Now let's create a Django project. Let's say it'll be the CMC CoinMarketCap project. I'm changing directory. Okay, and then I want to create an app. Let's say it'll be the coins app. I need the manage.py file. Start app coins. Also, let's apply migrations. Then, on the level of the manage.py file, I want to create the static folder and the templates folder. Static templates. In the static folder, I want to create the styles CSS. And in the templates folder, I want to create an index HTML file. Index template. Let's fill it with some content. I want to use Bootstrap CSS styles, getbootstrap.com, CSS only link. I want to paste it here. Also, I wanted to use Vue.js. Vue.js.org, get started, guide 3, installation, CDN package. And I need this script. Tag. Somewhere here. Then I need to add the templates folder and the static folder to Django. So I need the settings.py file. Here in the installed apps, I am appending my coins app. Then the templates last. It's theirs last. I'm appending with a new path. It's the templates folder, the name of the templates folder, and somewhere at the bottom I want to add the static files last and the same basedir variable, join path method, and the static, the name of the static folder. And in the index.html templates, I want to load the static function and to use my style CSS file. So I'm using the load tag, load static. Then here I'm creating a new tag, and the href attribute will be the call of the static function, and I am passing the styles CSS, the name of the styles CSS file as an argument. Then I'm going to create a new route, a new URL pattern, and a view to render the index.html template. So in the URLs PY, in the root URLs PY, I'm creating a new URL pattern. It will have the root URL address, and this pattern will include the URLs PY file of the Coins app. Then I have to import the include function and to create the URLs PY file in the Coins app folder. Here the same, from Django URLs import path. The URL patterns list gets a new element, a new path. It will be again the root URL address, and the handler of all requests to the root URL will be the index function. Let's import it. And let's define it in the views py file. The dot here means the current folder. So I need the views py from the coins folder. Def index, that gets a request object as an argument, and it will return the result of the render function. It gets the request object as the first argument, the name of the template that should be rendered, it will be the index HTML, and the context dictionary with some key, the text, for example, and the value. Let's use it. Let's use the text key, the text variable in our template. I need to add the standard bootstrap layout. Container div will have the raw div, 8 columns, for example, or maybe even 6. Then I want to have it centered and margin from top at 5 bootstrap units. And this callSex div block will have h3 header. And here I want to use the text variable, the text key of the context dictionary. And in the styles CSS file, I want to color the h3 header to the green. And let's test it. Let's run the server. Style CSS not found. Okay. Something wrong with my settings py file, because static CSS file is not found. So the load filter works well. So static files dirs, of course. Sorry for that. Let's try again. Okay. Now it's working. The next step is to get data from the CoinGecko API and render it on the web page. Let's install the requests library. Then in the CoinGecko website, coingecko.com, resources menu API. If you want, you can use the CoinMarketCap API, but you have to be registered and you have to get the API key. And the CoinGecko website allows us to use its API directly. So the coins section, and I need the coins market. Try it out. It wants the currency. I want to use USD and execute. And we will get this huge JSON object for the first 100 results, 100 coins. To get this JSON object from our Django app, we have to use this URL address. Let's copy it. Request URL. And now let's change the index function. Let's import the requests library. And in the index function body, I'm creating the URL variable that will be this address. After that, I want to perform a GET request to this URL address. So the coins variable will be the requests library. I'm calling its GET method, and I want to perform a GET request to this URL. This expression will return a response object. I want to have the response body serialized, so I'm calling the JSON method that will return the Python dictionary. So the coins variable is the Python dictionary. And then I want to pass the coins variable to the index template. Let's say as the coins variable. And I want to use the coins variable in the index.html templates. So let's close the styles and URLs here. I want to have the margin from bottom at 5, and let's start the for loop for coin in the coins variable, and here I want to paste the coin variable. Let's test it again. And we can see this data that we got from the CoinGecko website. Okay, it's working. And now I want to create a better HTML layout for these data. I want to use a table, and I want to use bootstrap styles. Let's delete it. So I need the table. It will have the table CSS class and the table hover CSS class. It will have the t-head tag, one table row, and maybe 3 cells in this row with a scope attribute. You can find it in the Bootstrap documentation. I need 3 cells, and I'm expanding this formula to this structure. I want to have the rank of the coin, the name, and the price. Then the t-body. And then I have to use inside the t-body tags the for loop, and for each element of the coin's list, for each coin, it will use the tr tag. Then in each row I want to use td table data tags. I need 3 td tags with align middle CSS class. td dot align middle. The first one will contain the rank of a coin. Let's turn back to the API of the CoinGecko. The rank is market cap rank. Copy it and paste it here. Coin.marketCap rank. Then the middle cell will contain the image, the logo of a coin, so the src attribute will get this URL. Image key. Then the name, coin.name, and the symbol. I want to use the small tag with the text muted CSS class. It's the Bootstrap CSS class, and paddings on x-axis will be 2 units. And inside this tag I want to use the coin symbol, and maybe the same for image. I mean, I need the class that equals to px2, and the price. The price will be coin and current price. Let's test it. Okay, image is too big. Let's set the width for this image at 15 pixels. Nice, very nice. I think that 8 columns will be better. Okay, I want to move the table to the left side for convenience, and that's all for now. The next steps are: I needed to create a model to save these coins data. I need to save it because I want to use the difference between the current price and the price of a coin that I will get in the future. And thus I need to save somewhere the state of the object, the state of currencies, of coins. Then I need to move the body of the index function view to a Celery task to execute it periodically. And after that I want to use a Vue framework to render changing data. So let's create a model for coins. In the coins folder, in the models.py file, I want to create a new class, coin, models model, that will have the name of the coin, the symbol, just copy it and rename it to the symbol. Then the price, it should be float field. Default value will be 0, blank 2. Then the rank should be integer field, the same, default 0, blank 2. And the image, it's a URL address, so it should be URL field, null true. And then I want to use the str method that will return, converted to the string, the name self, name of course, attribute. And I want to define the meter subclass to order these coins, order in attribute, and I want to order it by its rank. Okay, I have to create migration files and then I have to apply them. Manage.py, make migrations, and migrate. Great. The model is ready and I want to use it, but I want to do it in a Celery task. So, well, let's install the Celery with all its Redis dependencies. Pep install Celery Redis. As you probably know from my previous videos, Celery is a task queues management tool. A task can be any function you want, and a task can be the function that performs a request to an API, for example, or performs a web scraping, or maybe does long and complex calculations, and so on. All tasks are performed asynchronously, and thus it doesn't block the main process that runs our Django apps. Now I want to integrate the Celery to my Django project. Let's create in the child CMC project a new file, the celery.py file. Let's import the auth model. Then auth environment is a dictionary that contains all system environment variables, and I have to get the path to the Django's settings py model. To do it, I'm calling the set default method, and its first argument is the key, the Django settings model in uppercase. And the set default method will return the value of the Django settings model key of the environment dictionary. If there is no Django settings model key in the environment dictionary, it will create this key and it will assign to it a new value that it will get from the second argument. So the second argument is a CMC project. It's a path to the settings py model. So CMC project dot settings. So let's import the Celery class from Celery import Celery. Let's create an instance of the Celery class. It gets the directory that contains the Celery py file. In this case, it's the CMC project. Then I want to specify a prefix for the Celery configuration code, which I will use in the settings py model. So to do it, I'm calling the config from object method. The first argument is a Django conf colon settings, and the namespace will be Celery. The namespace is the prefix that I want to use in the settings py model. And then let's call the auto discover tasks method. And now let's open again the settings py file, and let's define here the Celery broker URL variable. It will be the URL of the Redis server. The default port is 6379. How the Celery works? Celery provides workers. The worker is a function that executes our tasks. A task, in its turn, is a function too that we define in our Django projects. Each worker is running in a separate process. And Django somehow should pass our tasks that we defined to these Celery workers, and usually brokers are used to do it. A broker is a task queue that stores our tasks. It's a data structure. After the broker gets a task from a Django app, it puts the task in a queue, and then it starts to pass this task to workers. After a worker completes its task, it will put the result in a so-called results backend, and then we can fetch these results from a Django app. Usually the same broker is used to store the results, and the most popular brokers are Redis and RabbitMQ. In this tutorial I'm using Redis, and so you have to install the Redis on your system. And thus the Celery broker URL variable contains the path to the Redis server. So I want to start it. the default port number of the Redis server, 6379, that I used here. And the last thing I want to do, I want to load Celery automatically when Django starts. So I'm opening init.py file of the CMC project folder, and here from .celery, dot is the current folder, this module. I am importing the app variable and save it as a Celery app variable. Then the all variable is a list, the list of names that will be imported with and the all variable is used with expression like from x import all when we use asterisk. And that's all. Now let's create a new Celery task. Let's create it in the coins folder. It will be the tasks py file, and here I want to import the requests library, and let's define a new function. Let's name it get coins data, for example. And let's copy here the body of the index view. Let's delete the context dictionary, and let's delete the import of the requests. We can close it. Tasks, and paste it here. Let's name it to the data. Then I want to save the data that I got from CoinGecko API to my database, and I want to do it here in the tasks py file. Let's import the coin model from .models import coin, and then in the body of the get coins data function I'm starting a new for loop, because I want to iterate through the data list and get needed data and save them to the database. So for coin in data. And then I need the coin model manager. Coin model, the objects attribute, and I want to call it get or create method. Get or create. That will return an instance of the coin model that was saved in the database already, or it'll create a new one. And I want to use the symbol of a coin as an identifier. So the symbol will be the coin variable, this one, the element of the data list, and its symbol key. Okay. The get or create method will return a tuple with two elements. The first element is an object, an instance of the coin model, OBJ, for example. And the second element is the created variable. It's a Boolean value that says whether the object was created or not. I got an instance of the coin model in the OBJ variable, and now I want to fill it with the data that I got from the CoinGecko API. I need not all data, I need only rank, name, symbol, image URL, and the price. Well, object name, it's the attribute of the coin model, the name. That gets the value of the name key of the coin object, the element of the data list. We get it from the CoinGecko API. The same symbol. Then the price, OBJ price. then the rank market cap rank, and the image, coin image. And I want to save the object to the database, so I'm calling the object save method. Then I think that I need an additional info about the price, whether the price is fall or raise or the same. So before the current price will be saved to the object variable, I want to check whether the values, if object price is greater the coin current price. If it's greater, the state variable will be equal to fall. Or if object price is the same as the coin current price, the state will be the same. And again, or if object price is less than current price, then the state is raise. Okay, I got the saved object and the additional info about the state of the price, and now I want to pack all coins into a list, and then I want to send this list to the front end via WebSocket connection. So I need a list, a new list, coins as empty list. And then I want to append the coins list with the data of each object and the state of the price. And we can do it with the model to dect function that I have to import from Django forms models, import model to dect. And here, after object is saved, I am calling the model to dect function, and I am passing into it the object variable, and it will return a dictionary. For example, it will be the new data dictionary that I want to update with a new key value pair. So I am passing into it a new dictionary with the state key and the state as the value. And that's all. And now I can append the coins list with the new data dictionary. It's done. I have created the getCoinsDate function. And now I have to say to Celery that it's my task and that it should be executed every 30 seconds. Let's import from Celery import shared task decorator and use it with the getCoinsData function. If you are unfamiliar with the decorator concept, consider watching of my Python decorators video. Okay, the task is ready, and now let's define its periodic execution. I need again the Celery py model, and somewhere here I'm going to configure the Celery scheduler, the bit. So app-conf bit schedule. It's a dictionary, and its key is the name of the task. Let's say it will be getCoinsData 30 seconds. And in its turn, it's the dictionary too, that has two keys. The task, it's the path to our getCoinsData function. So it's the coins directory, the tasks module, and the name of the function getCoinsData. And then the period of time, the schedule. 30 seconds. That's it. Let's test it. But to see that the task is working, let's add the coin model to the admin panel. So coins folder, the admin, from .models import coin class, then admin site register, and I'm passing the coin class into it. Also, I need to create a super user. Create super user. And now let's get to admin dashboard. We can see the coins models, and so we can see that there is no coins, 0 coins. And now let's start the Celery worker and its scheduler, the bit. But maybe it's better to reduce the period of time to, for example, 10 seconds. Then on the level of the manage.py file, I have to call the Celery command, capital A application, and then I have to specify the name of the directory that contains the Celery py model. It's a CMC project. Then what I want to start? I want to start the bit, and I want to see what's happening. So logger level will be info, and the same command for the worker, Celery -a CMC project worker info, and let's start it. Bit the worker. Task coins get succeeded. Okay. Refresh the page and we can see saved coins. Great, it's working. Stop it. Okay, the next step is to install channels, integrate it to the project, and to send messages from our task, from the getCoinsData function, to the channels consumer. So let's install channels. Pip install channels and channels-redis. And now I have to append the installed apps lists with the channels app. Then I have to modify a bit the definition of the asynchronous application that is defined in the asgi.py model that is located in the CMC project folder. So I need from channels routing import protocol type router class, and the application will be an instance of the protocol type router class that gets the dictionary, and its HTTP key will be the result of the getAsgi application function. And now I have to use this application. So in the settings py file, I'm copying this WebSockets application variable and change it to ASCII application. The path should be ASCII as well. Okay, let's restart the development server. And we can see that the ASCII asynchronous server is running. And now let's define a WebSocket, a router, and a handler, like we usually do with the core Django apps. Let's start with the router. We can define it in any file we want, but the preferred way is to create a special routing py file. And I want to create it in the coins app folder. Coins routing.py. And here, as usual, from Django URLs, import path WS URL patterns list. We'll get a new element, the path. It will be WS coins, for example, and the handler will be coins consumer class. I'm calling it as ASCII method. In Django core, such handlers are called views, as you know, but in Django Channels, they are called consumers. So let's import it from .consumers, import coins consumer. Then let's create the consumers py model. And let's define the class here, consumer. It should be an instance of the async WebSocket consumer class. From channels, generic WebSocket import async WebSocket consumer. Pause for a while because I want to use our WS URL patterns list. I need again the ASCII.py file, and the application dictionary gets a new key, WebSocket. That will be an instance of the auth middleware stack class that gets the URL router instance, and it gets our WS URL patterns list as an argument. So let's import from channels routing a URL router class, and from channels auth import auth middleware stack class. Then from coins directory, from routing model, let's import our WS URL patterns. That's all. Here, let's define the connects method to accept the incoming connection from a WebSocket. And as the coins consumer class is a subclass of the async WebSocket consumer class, the connect method should be coroutine. So async def connect that gets the instance of the coins consumer class, the self argument, and then I want to accept the incoming connection. Await self accept. I want to add the incoming connection to a group of channels. To do it, I'm calling the group add method. Again, await self channel layer group add, and it takes two arguments. The first one is the name of the group. Let's say it will be the coins group, And the second one is the channel name. Self channel name. The channel name is assigned to a channel automatically. So it's time to configure the channel layers in our settings py model. Somewhere here, I'm creating the channel layers variable. It's a dictionary, like the databases. And as you remember from the previous videos, the channel layer is an ordered first in, first out data structure. It's a queue of messages, queue of tasks that this data structure receives from its clients, from the producers. And for every message on the channel in this queue, in this data structure, Django will call the assigned consumer. In my case, for each message, for each task in the channel, Django will call the coins consumer class. So to use the channel layer, I want to use Redis as a message broker, as I said earlier. We can specify here many layers, like we can use several databases, but the default layer will be enough. Default in lowercase. It's a dictionary too that has the backend key, and the backend will be channels underscore redis.core redis channel layer. And then I have to specify my Redis server. It's the config key. It's a dictionary. That has the host's key, and the host's key is a list of IPs. And the port number 6379. That's it. Okay. Let's back to our consumers. And now I want to define here the disconnect methods. Just copy the connect method and gets the closing code as the second argument. Also, I'm calling the group discard method. And I don't call the accept method. And now I want to send a message to the coins group, and I want to do it from the Celery task, from the getCoins data function. So let's open the tasks.py file. And first of all, I have to get the default channel layer that we described in the settings py module. And that is used by the coins consumer class. I added a group to it. So let's define it. The channel layer. And I'm calling the getChannelLayer function that I have to import. From channels layers import getChannelLayer. The getChannelLayer function is an asynchronous function that I want to call from the synchronous function from the getCoinsDate function. To make it possible, I want to use the async to sync function. Let's import it. From ASCII ref sync import async to sync. And then in the getCoinsData outside the for loop, I have to call it async to sync. As an argument, it gets the function as an object that should be converted to a synchronous function, and I have to pass into it the group send method of the channel layer instance, channel layer. Group send. And I want to notice that I pass the method as an object, I don't call it. And the async to sync function will return the group send function as an object too, but it will be a kind of synchronous version. So I have to call it. And the group send method takes two arguments. The group name, the first one, it's the coins group. And the second is the message. It's a dictionary that has two keys. The first is the type. The type is the name of the method of the coins consumer class that will handle the message. Let's say that it'll be the send new data method. Send new data. And the second key is the text. And as the value I am assigning into it the coins last. Coins. This last. Type and text. Okay, I said that the handler of the message will be send new data function method. Let's define it in the coins consumer class. Async def. And it gets the event as the second argument. The event is our message that was sent by the getCoinsData function. Let's get the value of its text. New data, for example. Event text. And now let's send it to all clients in the coins group. I'm calling the send method, but I want to send the coins last as the JSON objects. Let's import the JSON module. Import JSON. JSON dump string that gets the new data list. It's done with the server side of the WebSocket, and now I need the client. I want to use Vue on frontend. Let's close tasks, Celery, consumer, admin, routing, settings. I need the index.html. And before the closing body tag, I want to add the script tag. But as we're using the static folder for static files, you can write JavaScript code in the separate file and then just add it to the index.html file with the static function, like we did before. And here, in the script tag, I want to define a Vue object. The Vue class has the createApp method that I want to assign to the createApp constant. Const, and inside curly brackets I'm defining the name of the variable, the constant createApp, and I am passing into this expression the Vue object. Then let's define an object that will be used by a Vue.js library. Let's say that it will be the coins app object. And now I want to create an instance of the Vue from this coins app object. I'm calling the create app method and passing into it the coins app object. And then I want to bind the Vue object with an HTML tag. I'm calling the mount method that gets the identifier of HTML tag. So I said that I need a tag with the app ID. So let's wrap my table with a div. with the app ID. That's all. Then in the coins app object must have the data function that will return an object too. And this object will have the message key, for example. Message will have the hello world value. And let's use this message variable in the templates, for example, somewhere before the table. As usual, curly brackets, message. It's the same idea like we have in context dictionary of Django render function. So let's refresh the page. Cannot import ASCII application model. No module named coins routings. ASCII line 17. Sorry, a typo. Again. Okay, and there is no hello world message because Django and Vue use the same paired curly brackets delimiters. And to turn off Django template language for the table, I want to use the verbatim tag. Somewhere here. Verbatim. Ctrl C. Ctrl V. It should be end verbatim. Closing tag. And let's again refresh the page. The table is disappeared. Inspect console. And we can see that the market cap rank is undefined because it tries to get the market cap of the coin variable that is not defined in the data dictionary. So let's delete all these attributes of this case and let's define a coin just as dummies. Coin again. Okay, we can see the hello world message and it doesn't like our for loop for coins. Okay, let's delete it. Okay, we can see our hello world message that was defined in the Vue object, in the data object. And also Vue created one table row, but we have 100 rows that we should get from the WebSocket, from Django side. Let's get data first. So in the data dictionary, let's define the coins key. Coins that will be null for a while. Let's delete the message. Also, let's delete the message from here too. And then I want to use the created hook. It's a function that will be called when the Vue instance will be created. And here I'm defining a new constant, socket. That will be an instance of the WebSocket class, new WebSocket. And as an argument, it gets the URL of the WebSockets, the same as we defined in the routing PY module in the WS URL patterns list. So I am using here this characters, it's in the tilde button, and then WS, then $character, curly brackets, and I am pasting into it the window location host. This expression will render here just localhost 8000 port number, the default location host. WS coins trailing slash. Don't forget the trailing slashes, like here. It's something like F-string notation in Python. The next important here, I have to save a reference to our Vue instance to a variable. Let underscore this, that will be this. So then I have to define the onMessage method, like we did before, socket onMessage. It's a function that will get an event from the browser. After we get the event object, we need to get the JSON object that was sent by Django, and I want to save this coins list from the event object to the coins key of the data object. And here we have to use this keyword. But the problem is that the onMessage function has its own this. That is why I saved the reference to the Vue object in a variable. So underscore this coins, and in this time this coins will refer to the coins key of the data dictionary. This coins JSON parse event data. That's it with the WebSockets. Now the layout. I have to create TR tags for every coin in the coins list, and I need the for loop for it again, like we use in Django template language. So the TR tag gets a new attribute. The v4 attribute, it's a Vue directive. And the syntax is familiar for us. For each coin in the coins list, the coins is the key of the data dictionary, and it will contain the list of all coins. On each iteration of the for loop, the coin variable gets an element of the coins list. It will be an object. But to use the for loops, we have to identify each element of the list. So the TR tag gets a new attribute, the key. And the key will be the coin ID. And as a key, I want to use the ID of a coin object. I want to remember you that each coin in the coins list is a serialized instance of the coin model, and so it has the ID attribute. And then inside the for loop we can use needed data. The coin rank, the coin symbol, the coin price. The rank, the symbol price, the name, of course, and the image. To render the URL of the coin properly, we have to set the source attribute in a different way. So I have to set here the colon before the src attribute and delete these delimiters. Let's test it. Let's restart the bit. Let's restart the worker. Unexpected response code 500. It means that something wrong with our consumer or server side. Missing one required positional argument code. Consumers, because I forgot to disconnect to rename the method when I copied and pasted here. Disconnect, of course. It's a dark side of all copying and pasting actions. Disconnect. Again, the Celery, Beats and Walker. Okay, we got the result. Great, it's working. And the last thing I want to do, I want to highlight the price with red if it's false and with green if it raises. And so in the styles CSS files, I want to delete this, and let's create a new CSS classes. The fall will have the color red, and the raise will color lime green. Full raise. And the price cell, this one, will get a new class if the state of the coin will be raise, fall, or the same. And I have to specify the conditional class, colon class, that gets the dictionary as the value. The key of the dictionary is the name of the class that will be added when its value will be true. So this TD tag gets the raise CSS class if the coin state equals to raise. And the same, it will get the fall CSS class if the coin state equals to fall. Let's increase the time in the tasks in the Celery API model to make the difference in price significant. And let's test it again. Let's restart the beat and the worker. Beat, worker. Control F5. Okay, it's working. It's working. So if you like the video, please leave a like and subscribe to the channel. Thanks for watching.